Hi, I am Pushkar, Master Teacher in Chemistry at Vedantu. I am solving JEE Advanced 2019 Chemistry paper. So let's start solving a question which has been asked in paper 2 and the question belongs to chemical kinetics. In this question, decomposition of N2O5 is taking place and the equation for this is twice of N2O5 is breaking into twice N2O4 plus O2 in a closed container, cylinder, in fact, in isothermal isochoric conditions at an initial pressure of 1 atm. After y into 10 to the power 3 seconds, the pressure inside the cylinder is found to be 1.45 atm. And if the rate constant of the reaction is 5 into 10 to the power minus 4, assuming ideal behavior, the value of y is, we have to calculate the value of y and truncate after 2 decimals. So the basic fundamentals of this problem, let's first discuss the basic fundamentals of this problem, which is to start with that if we write this equation like twice of N2O5 is breaking into twice of NO2 plus O2. So we have to keep it in mind that if we write the rate law, then minus 1 upon 2 d of N2O5 upon dt is equals to k times of N2O5 raised to the power 1, and which means that minus of dN2O5 divided by dt is equals to twice of k into N2O5. The purpose of solving this equation in such a manner is to give you this important fact that when you write the integrated expression for this, the expression looks like this. Twice of k into T is equals to ln of initial pressure P naught upon final pressure Pt. It will look like this. So idea is this. So we have to find the initial pressure and the final pressure Pt after time t. To do this, once again, let's write this equation N2O5 breaking into twice N2O5 breaking into twice of N2O4 plus O2. And we can see the initial pressure is 1 atm. After some time, the pressure will become 1 minus x. This will be x and this will be x by 2. And it is given the sum of these pressures at time t is equals to 1.45 atm. Upon solving, we can get 1 minus x plus x by 2 is equals to 1.45, and which gives us that x is equals to 0.9. X is 0.9 means the pressure here will become 0.1. So that means pressure after time t will become 0.1. So if we substitute this in this equation, then k into t will be ln of 1 upon 0.1, which is simply ln of 10, which is simply 2.303. Now we have to find the value of k, which is given as 5 into 10 to the power minus 4. So we can see that 5 into 10 to the power minus 4 into the t is given as y into 10 to the power 3 seconds. That means y into 10 to the power 3 must be equal to 2.303, and which gives us y is equals to 2.303 divided by, I forgot to add here 2, so let me multiply here 2. So if we multiply this, then we have y is equals to 10 into 10 power minus 1, and that is simply equal to 2.303. So let's see what is there in the printed solution. So that will be the answer. So t is equals to 2.303 into 10 to the power 3. We can see here which is y into 10 to the power 3. So y is equals to 2.303. And after rounding off in truncation, the answer is 2.30. So what are the major highlights of this problem? First of all, you can see in this solution, we have also provided the solution in which we have solved the problem in a different manner. Here we have used this equation P infinity minus P naught divided by P infinity minus P1 is basically equals to P naught upon Pt. You can verify this result. So the idea is the problem is special because the first time JEE has given a problem in which we have to take into account this kind of integrated rate expression. So that is how this problem is slightly special this year in 2019. So henceforth, because generally students before this examination, generally students used to ignore or they're double-minded whether JEE is going to ask the questions like this, okay, and whether JEE is going to ask a question in which there is a coefficient 2, so whether to take this approach or not. So this is the perfect way of solving the problem, and in fact that was very much on the cards because in many previous examinations these kind of questions that integrated expression was not taken as 2k, but this time definitely 2k is needed. So once again I tell you important feature of this is that the rate law, integrated rate law for this is equals to twice into k into t is equals to ln of p naught upon pt. Thank you for watching this video and stay tuned for detailed solutions of other questions.